My name is Magnus Hagander. I'm here today to talk to you about a look at the elephant's trunk, or what will, hopefully, become Postgres 16. So I know some of you were in my talk yesterday when I talked about Postgres 15. So let's try the same thing I did then. Who's already running Postgres 16 in production? You don't run production servers, sir. I know you. So that's probably a good thing because there isn't yet anything called Postgres 16. But we are looking at what will eventually become Postgres 16. That means a lot of the things that we talk about today may or may not actually show up. But we'll look at the things that we have in it. If you go and download what looks like Postgres 16 today, they may not remain, but it's what we have today. So a few quick words about myself. As I said, my name is Magnus Hagander. I work for a company called Red Pill Infra. We're an open source services business in Scandinavia. So I'm out of Stockholm in Sweden myself. Within the Postgres project, I'm one of the core team members. I'm a committer on the code base. I work for Postgres Europe, which does similar things to this. The PG days here are arranged by Postgres US, and we have a similar organization in Europe that does this type of stuff over there. And then I have a whole bunch of other smaller hats within the projects, like on the website teams and on the infrastructure teams and all of those. So, enough about that. Let's talk about Postgres 16 and the reason why you're not running it in production, right? So the life of Postgres 16 started in June last year when we created Postgres 15. Like I said, if you want to know about all the new cool features in Postgres 15, get in your time machine, go back to yesterday, and there was a presentation at the same time in the same room by the same person. It started then, and then the way that we work in Postgres is we work in something that we call commit fests, which are our iterative development model where, in theory, we spend about a month building things, and then we spend a lot of echo. Let's move that one a bit further out. We spend about a month reviewing and getting that code into the main code base. And we typically run 5 of these for a release, which accounts then to 10 of the months of the year. And then we have 2 months to stabilize the release and actually get it out. So we had a commit fest in July. We had one in September. We had one in November. We had one in January. And you'll notice all these years are wrong. That's what you were going to point out to me there? Yeah. Actually, yeah, all these years are wrong except for one. The June 2022 one is right, but we didn't actually go backwards in time. So all the 21s later should be 22, and we are currently in March 2023, and we're at the beginning, I think we can still say, of Commit Fest 5, because it runs throughout March, which is why we really don't know yet, because at the end of this 5th Commit Fest is when we have the feature freeze, and that's when we really, well, we still don't know, but we know better what's going to be involved. But a lot of things will happen through this. And it also is that this last Commit Fest is typically extended to be a little more than a month. It's extended by like 1 to 2 weeks extra because it's the last chance to get things in, right? But also nothing completely new. Like if someone drops a big, really good, wonderful feature into this last Commit Fest, it's not getting in. Right, it takes longer to evolve, but we have some very big things that have been coming with us, some of them already from last Postgres release that keeps coming back, that may get in towards the end of this commit fest that we don't know. And of course, once we finish this 5th commit fest, we'll eventually get to a beta version, and then we'll get to a release candidate, and then we'll get to a release. We really hope we will get to a release. And usually we target having a release in September or October. So that's approximately when you can expect it to drop. But that also means that it's not actually until the release that we know that things are going to be included. Last year, at this time, we would present, one of the cool new features in Postgres 15 is going to be SQL JSON support and JSON table support, and that didn't actually happen, even though it was committed. So that's a disclaimer about the things that I'm talking about now. They may be in the code today, but if we end up finding out that they're not good or they need to be revamped too much, they will actually be removed again. So these are good indications of what's going to be in Postgres 16, but we don't actually know for sure until we get there. So what is actually in there, though? What do we have? What do we have to look forward to? We got a bunch of things. I usually group them up in these categories of DBA and admin, SQL and developer-focused feature, backup and replication, and then of course, everyone's favorite of performance. Nobody wants a database that runs slower. So there's a bunch of things that are happening around that. But let me start with a few things that will break stuff. Because as you know, we'll always break things. But hopefully we're not breaking things that are causing you problems. One of the things that we haven't done this for a long time, but we bumped up the minimum versions. So Postgres will no longer run on Windows prior to version 10. Hopefully, I don't think there are any Windows versions prior to version 10 that are actually supported by Microsoft anymore, I think. But either way, Windows 10 isn't exactly new anymore. So you will need that. And speaking of things that aren't really supported anymore, we've removed support for HPUX and for the Itanium platform. Who's ever run Postgres on the Itanium platform? Who's ever run anything on the Itanium platform? Who's ever run HPUX? Okay. See, I'm going to try to say this in a nice way, but you guys are the old ones in the room. There was a very clear pattern of the people who put out their hand up on HPUX. Yes. Yes, I am. So the fact is, I don't think, I'm sure there are supported HPUX versions still, because that feels like one of those operating systems that's going to be supported for 200 years. But we're not seeing new stuff on it, right? So I don't think we're even sure that these worked, because nobody's been using it for a while with a new version of Postgres. So these should hopefully also not cause a problem. And of course, again, Itanium never really took off. Something that you may get hit by, though, is that the promote trigger file is gone. So for those of you who've been with us with Postgres for a while now, we used to promote replicas by putting a trigger file, and then the replica would promote. And you controlled what this trigger file would be with the parameter promote trigger file. And then sometime many years ago, we added the ability to also use PGCTL. So you could say PGCTL promote, and then we kept both ways of promoting replicas. Trigger file is now removed, and you have to use PGCTL promote. And I'm sorry, there's not supposed to be an underscore there. It's PGCTL space promote. Or you can use the function pgpromote inside of Postgres. But this trigger file functionality has been removed. So if you have promotion scripts or integrations with your automation that uses the trigger file, switch to using PGCTL. The other methods, PGCTL promote and pgpromote, are supported on all older versions of Postgres that are currently supported as well. So you can safely make this change on your current platform and then upgrade. Okay, let's take a look at a few of the new things that are coming in. You can now use PSQL. PSQL can now use the extended query protocol. Sounds exciting, right? It's extended. Must be better. What it means in practice for you is that you can now use PSQL to issue queries with placeholder variables. So you can say, in this case, I just use something of PG class, count PG class, where rel count equals $1 and rel name not like $2. And then you can bind with the new PSQL command bind variables to it, and then run it. I think the commit message to this one said, this is primarily for testing. And I think that's a very useful case, but it's also a way to make sure that, because this is how you run your queries from your applications, probably. Under the hood, this is what you run from your application, so you can check it. You can get it to test out things like how does the system behave with prepared queries and things. Yes? Does So the question is, does that also work with explain to see the difference between when you're using placeholders or not? I think it does. I don't see why it wouldn't, but I've not actually tested it myself. But the way that it works, I think it should work, but I'm not sure. Please test and let me know. We have a new one of these virtual variables, or what you want, called system user, which will tell you what user was actually used to log in. We already had current user, right? And system user is a way to show where this came from. So in this example, in this example, I'm selecting current user and system user. Current user is MHA, that's me. That's my Postgres username that I'm logged in with, the role that's currently active. System user here is peer::MHA. So the way that it's the authentication type : authentication name. So for example, if I was logged in with Kerberos from my Active Directory, it would say gss::MHA@redpillinpro.com probably, right? And then you can get the full traceability to see where the user actually entered your system from. I think it's also, if you set trust as your authentication method, it will say null, so that's a good warning. Don't ever do that. Don't use trust, it's evil. But other than that, it will show you. So if you're logged in with a password, it will hopefully show you scram SHA-256 : username. If it shows MD5 : username, you should upgrade to use scram. But it gets you a way to see where the user actually came into the system from. System user is a SQL standard name. The format of it is not defined in the SQL standard. It's set to be implementation defined, something like that. So the format of it is Postgres specific, but the name of it is in the standard. Speaking of authentications, we've had some enhancements to the PG-HBA and the PG-ident configuration files. They can now use regular expressions. So you can match your users and your databases, not just by saying the names of them or saying all, but with any sort of regular expression. So in this example here is the user field. First we've got host on both times. That's the type of rule, right? And then we're matching the user, any user starting with dev. So the way it works is if your name of your user or the name of your database starts with /, it will be interpreted as a regexp. So we're here saying any username starting with dev is allowed to log into any database starting with dev, but not anything else. And then the usual, from which IP, how to log in. And that's a beautiful copy-paste, right? It's scram SHA-256. That 4 is not part of it. We haven't upgraded scram that way. It's scram SHA-256. We've not added any more bits. I'm sure that will haunt me forever. So you got that. Same thing, you can map them, it still works. Same user is still a keyword as it was before. If you set user to same user, it means the user can log into a database with the same name as their own username. So here you're basically saying any test user can log into their own database if they're coming from these IP addresses. So the first line will let dev4 log into the database dev5, whereas the second one will only allow you to log into the database that matches your username. So that part hasn't changed. The new thing is just we can add regular expression parsing. We already had regular expressions in the PG-ident file, just not in the HBA file. And both HBA and ident have learned how to do proper include files. So, we've been able to do, for example, in PG-HBA, you've been able to use the @ syntax to say, here's a list of databases in a different file, and you can point to that. But you haven't been able to do a simple, just include a different part of an entire configuration file. And now we can do that, and the syntax is exactly the same as in PostgreSQL.conf. So if you say include, you can say include if exists, or include directory, right? Which will give you these conf.d directories. This can simplify a bunch of cases where you might have configuration management systems that want to generate a list of rules in numbered files in a directory. It will just read those files and substitute them in where the include part is. So yeah, that'll be a useful part. You can still do the include lists, like the @ thing to just get a list still works, and you can put it at any point. We've continued the work towards getting rid of your needs to use superuser. So there is a new permission type. It's called a maintenance permission. Normally, the only people who can do maintenance on a table, and by maintenance we mean vacuum, analyze, cluster, reindex, refresh a materialized view, and locking the table with an explicit lock. You needed to either be the owner of the table or a superuser. The new thing here is you're now able to grant this on a specific table by saying grant maintain on the table, or of course, or on a materialized view if you're looking for the refreshed materialized view, for example, to a specific user. And there is a new global, what do we call them, default roles, predefined role. Sorry, we used to call them default roles, we call them predefined roles now. A predefined role called PG maintain, which will let, in this case, if I do grant PG maintain to test user now gets permissions to do, vacuum on all my tables and lock exclusive on everything. So it's a relatively high permission at that point, because you can say lock table PG class in access exclusive mode and nobody else can do anything. But you can't at least ruin, well, you can ruin things, but you can't ruin the data. So again, it's part of the work to chip away at needs to use superuser. Hopefully it gets rid of a couple more and people can just stop using superuser for their applications. Don't do that. As everyone knows, Postgres has this thing called vacuum. And there's been a bunch of interesting things happening in vacuum. One thing is just at the pure instrumentation level. It's not actually just auto vacuum instrumentation. All vacuum that runs in verbose mode will now tell you information about page freezing. Does everyone know what page freezing, or tuple freezing, I guess is the actual word for it, what vacuum freeze does in Postgres? Has anyone ever run into this transaction wraparound, or just auto vacuum firing a transaction wraparound vacuum, right? That's when we do the vacuum freeze. And traditionally, Postgres does this when we hit, auto vacuum will trigger this after certain 100 millions of transactions, and it has to happen before you hit 2 billion transactions, right? And if you go back to the really old days, when we didn't have auto vacuum and you forgot to do this, you were in real trouble. Now you're just in big trouble, because doing this can be very expensive. So as one step, this one will tell you how much ends up being frozen, but the other really cool thing around vacuum that's in 16 so far is that we can now do page level freezing, right? You don't need to vacuum a whole table to do this freezing for the tuples on a page. This means that it can be done in a much more incremental way, so it's sort of on demand, because a lot of the time when something happens that updates the whole page, it's sort of like, well, then we can just go ahead and freeze whatever we can on this page while we're at it at a very low incremental cost. Whereas scanning and freezing huge tables can be very, very expensive. So we end up freezing much earlier, which means that and we do it at a page level. So instead of just looking at one, it'll look at the whole page at once and decrease the cost of these repeated full table scans to do the freezing. There were some other works done to sort of enhance the freezing level, which I think went in and then went out again. And we'll see whether they come back in for this version or for another version. But it's part of a very long-term effort to make vacuum less painful. Any one of us who's been around Postgres for a long time knew that vacuum used to be a lot more painful than it is today, but there is still a lot more that can be done. This is also something that it'll just happen. You don't have to do anything, but it will change how your system behaves in certain types of application. Anyone who's been following these talks from me before know that I like every time we add new statistics to the system, that lets me, as a DBA, get insight into what's happening in the system. We did a couple of things. This is one of those things that has been requested many times over the years and just didn't show up, but we can now track the last scan of a relation separately for sequential and index scans. So basically this is the pgstat user tables view, or the same for pgstat system tables, of course, but it's the user tables that's usually the interesting one. And as you can see, you will now get you got, in this case, the sequential scan 13. This table has been scanned a massive 13 times, and the last sequential scan was on March 5th. So this can be a way to see as things are changing. Yes?
Are there plans to differentiate between different index scan types, like regular PG scan different?
So the question is, does this differ, or are there plans to make it differ from different types of index scans? I don't believe so. This is just sort of the general, you can see when sec scan versus index scans and how these things are dealing. It's one of the many things that you need to like find the right granularity where the overhead isn't too big. Part of this is helped by the new statistics subsystem that went into Postgres 15 that has made these collections cheaper. So it may be that we can get more around it, but I don't know of any other such plans right now. Another statistics addition that I'm personally very excited about is that we now have a pgstat.io view that contains much more detailed I/O statistics. It enhances, the pgstat.bg writer had a lot of really interesting information, but then it had like the one column that had 15 different things in the same column, so you couldn't really understand what it meant. So it is a global view. We already had a bunch of statistics on a per table view, but this does a global view, but it does so by type. So you get a bunch of rules. So for example, this was a query from my laptop just after I'd installed it. You'll get a bunch of rows. In this example, it says, so a standalone backend doing normal I/O to a relation, so to a table or an index, so this is basically normal I/O, has done 689 reads and 1,008 writes. So that's summarized across all the backends through the lifetime of this process, right? Has done that much. It has done 493 extends, so that's the number of times it's extended the files that's backing a table. The individual I/O has always been, these are blocks of 8,192 bytes. Right now I think every single value means that, but it's getting ready for futures. There are things like buffer evictions, buffer reuses. Those things will show up when you have like large scans running in ring buffers and stuff like that. You'll get a lot more details. You'll have similar values for like how much vacuum has been doing, like your auto vacuums, how much has been generated by different types of backends throughout different contexts. So it lets you get a much deeper view. And there is actually even more, hopefully, there is even more coming to this view with even more detailed statistics. Hopefully it's coming for 16, but it's still being worked on. The locale system in Postgres has changed. ICU-based locales are now the default if Postgres is built with support for ICU. But I think all major platforms today build with support for ICU. So prior to that, the default was to use the libc, so glibc on Linux or Windows libc on Windows. Now the default is to change to ICU. It'll still pick it up. So as an example, this is the output that I get from initdb on my machine now. It will just come up and it'll say database system will be initialized with this locale configuration, provider ICU. So that's how you see that it happened. In this case, it's just picked up the ICU locale SV, which is Swedish, and it has set lc collate to svsc.utf8. That's based on, it still picks it up from the language settings in the environments that it's running. So for most people here, it would probably still pick up enus. That's the default, right? But it will just use ICU instead of glibc to get there. You can, of course, still override this. You just pass it, but now you have to pass a parameter to initdb that says use libc instead of ICU. So let's move on and look at a few things from the SQL and developer side of things. We've added a new aggregate function. Very useful, right? It's called AnyValue. Can anyone guess what it does? It gives you any value. The idea behind it is it's actually a query type that is very common. Right? You group by something and you say, I don't really care which of the values I get in this group, I just need a value from it, like a sample value. So in this here, you're just saying, you know, rel kind, account, and then any value. It'll just pick any value. Now, in theory, this could be very fast. The Postgres implementation of it isn't actually very smart yet. So it won't be substantially faster than saying first value or max or something like that. Hopefully it will be in the future, but it's not right now. But it is also a SQL standard aggregate, so it will help you in migrating. And as always, if you really don't care which value, you just want any value, tell the system that so that it can potentially optimize it, even if it doesn't do it today. You can now set the storage parameter for a column when you create it. Previously, you had first create your table and then change the storage. Which is one of those, actually when I saw this go in, I realized like, what? We couldn't do that before? But actually we couldn't. So basically, If you want to create your table with a text column that has external storage, these are how toast columns are processed. External, which memory serves me right, means turn off compression. You had to create table with text and then do alter tables at storage. And now you can just do it right away. Okay. Simplifies life. I like things that simplify life. We can now do non-decimal literals for integers and numeric. What does that mean? Well, it means you can now write your queries with numbers being input as hexadecimal, as octal, as binary. And we also allow random underscores in your numbers, because apparently there is a standard for that, which is interesting. So basically, you can do queries like this. 0x123 makes it hexadecimal, 0b makes it binary, and just 0o makes it octal. And of course, internally, it gets turned into an integer directly as you enter it into the system. And then, yeah, you can put random underscores more or less wherever you want in a number, and Postgres will just ignore it. But it's a way. I don't know if I would approve of, the first example here of 0x12_34. Like, that's a very strange place to put it in, but you can. The normal place would be to put it like every 3 digits, right, to get your 1000 separator while keeping it in a number, but you can put it anywhere. And you can put it at the very beginning, so 0x_, but you cannot put it like, you can't do 0_x. Then it will just say, this is not a number. Go away. But you wouldn't want to do that. Yes? So the question is, does it work for output as well? I believe we have formatting functions for that, but you have to turn it into text. So you can use the format function or some to-text to generate that. But obviously you can't return it as an integer in hex format in binary, yeah. But yes, and that's something you can already do. Like you can do that previously, it's just the input that you couldn't do. In fact, there are ways to do this in current versions of Postgres as well, where you call a function that converts it for you, and this is just a lot more convenient than that. Much as we like the ability to do things from functions and stored procedures in Postgres, this is not something that should be there. Okay, let's move on and look a little bit around the areas of backup and replication. I'm going to counter myself because I don't like to put this slide here, but I put it here anyway, because I don't like to call pgdump backups. But it's called a backup tool in our documentation. So I just say if you're using pgdump for backups, you should really look at using something better for backups. It doesn't mean that pgdump isn't a great tool for many other things. So there is a new compression layer in pgdump. So number one, it changes the syntax for how you specify compression. And it does so in order to support more than one compression method. This is the same syntax, by the way, that pg-based backup, for example, already uses. It's just that pgdump wasn't up to speed. So previously, you would say -z9, and you would get gzip. Given that we now support more than one type of compression, you just give it compression type : compression level. But in particular, we've also added support for LZ4 compression, which in some cases can yield better compression. In my experience, those are few and far apart, but it tends to generate much faster compression, which has a value in its own. There is work ongoing to possibly also add ZSDD support. We'll see whether that gets in. It's not there yet, but if so, it will just use the same syntax to go in as well. There are some enhancements to our logical replication. We now have at least the beginnings of parallel logical replication of an individual publication. You can, of course, already do parallel if you put your things into different publications, but then they have to be, you get into trouble if you have transactions spanning multiple publications and those things. So we now have something called parallel apply workers, where we can start a number of background workers on the receiving side to apply our incoming replication data in parallel. To make it faster, because I'm sure if you have tried logical replication on very high rate systems, it can fall behind. It's not super fast, because on the primary we might have 20 CPUs and 20 sessions generating updates, and then we're going to replay all those on a single CPU on the receiving side. Which is a problem, and it's also a problem for physical replication, but it's a bigger problem for logical replication because there is more overhead. And then there is this thing about performance. There's always a lot of cool things about performance. Sorry, Jonathan? I'm sure I missed many things on the replication side. I did. I'll be happy to talk to you about that one later. So under performance, there are a lot of infrastructure things under performance that will just make things run faster. I looked through like a bunch of these. When I make these talks, I go through the commits, I make a long list, and I sort them, I go through, and it goes like, how do I make a slide about this? Like, how do I explain to people what this actually does? For example, there are a couple of commits that just, yes, memory management in Postgres is now faster and has less overhead. I'm like, okay, sweet. Okay, it runs faster. Everybody's happy. Woo! But one thing that's kind of interesting is we've added, Devrim, remember from yesterday? Pay attention. We've added explicit SIMD support for Intel SSE2 and ARM Neon, which is explicit use of like vector operations and things, explicit use of low-level CPU operations that we have. We have these things on all platforms. Like Postgres already had the ability to allow the compiler to do a bunch of things, but there are things that the compiler cannot know, and there are things where the compiler has to be more generic in what it outputs. And these are not, there's not a huge amount of them, but some things that are very central in Postgres, like, was it one sorting transaction IDs or something like that, like in the visibility checks, can now use these very optimized instructions that just makes things run faster on modern CPUs. And guess what? In this regard, you all have modern CPUs. Like they all have, these are like Intel SSE2 is not exactly new. But it's again, the difference is that we've added explicit support for it. We've already had the implicit, but there are limits. We know more about our code. Actually, I'm not sure about that. But in this particular case, we know more about our code than the compiler does. In a lot of cases, surprisingly enough, I think the compiler knows more about our code than we do because we think it works one way, and that turns out it actually didn't. Speaking of things that we have on modern CPUs, we have a lot more of them. We have a lot of CPU cores. We can now do more parallel aggregates. String ag and array ag can now be run in parallel, which doesn't, of course, just mean that these aggregates in themselves can be parallelized, which they can, and that's great. But they can also participate in a parallel plan that where the actual gain of the parallelism might be elsewhere in the plan. But it just enables, even more things to use parallel query, which, good for everyone. Distinct queries can now use limit. That's also one of those. Okay, that sounds good. Doesn't need you to change anything, but the fact is that normally, when you do a select distinct on something, that's actually pretty expensive because it has to run a uniqueness check across it. In my experience, I see a lot of, like, when I go out and look at customer systems, a lot of the time when they actually use distinct, it's actually because they forgot a join clause somewhere. But when you do need it, it can be expensive. Now, Postgres has a new way of running a distinct. So this is a sort of enforced way of showing it on PG class. I'm not sure how you'd ever do this, but in this particular case, select distinct rel name from PG class where rel name equals may not be what you would normally do, but actually this is a surprisingly common thing because of auto-generated queries, right? They don't know for sure. We know that, well, actually we don't necessarily get just one value back, right? There could be multiple test tables in different schemas. But a lot of auto-generated queries might just throw a distinct in there for good measure. Now the difference here is that Postgres can use this planning node called limit. If you went to Bruce's talk yesterday, he went through a bunch of different planning nodes. Like the idea with limit is it only has to look at the first row. And in particular in this case where we can combine it with an index scan, we can stop scanning the index after we find the first row. This same query, obviously you don't have millions of tables, so PG class isn't actually big, but this type of query on a previous version would have to scan the table for every entry for test and then do a uniqueness check on them. But here, since we know it's going to be unique, we can just stop at the limit point. So it's one of those. You shouldn't write your queries like this. I'm sure you don't if you write them by hand. But a lot of our queries today are not actually written by hand. Speaking of, there are a bunch of other enhancements to group by and distinct. distinct and group by are very closely related, right? You can actually do distinct by saying group by and not adding any aggregates. It becomes a distinct. So it does smarter sort orders for aggregates. I tried to find a good example of that wasn't just entirely contrived, and I couldn't really find it. But if you have multiple aggregates in a query and you have order by in the aggregate, string ag order by this, stuff like that, it can do much smarter scans. It can know about this. It can combine this with the incremental sorting stuff and stuff like that to make it faster. And it knows how to remove redundant grouping. For example, again, common in auto-generated queries where you have select A, comma B, comma count star, where A equals B, or something like that. It doesn't actually have to group by both of them because it knows they're the same. So group bys and distincts in a lot of those cases will run faster. Something that sounds scary to me at first is that window aggregates, so window functions are now allowed to alter their own options. That sounds scary. Like you set a bunch of parameters for a function, you run it, and it can change those parameters. That seems scary. But it's actually smart in a lot of ways. So a lot of functions don't actually care about whether the window that they're running on, the window that can be, unbounded proceeding to current row, for example, or it can be unbounded proceeded to current range. We give rows that counts number of rows, or range that counts range of values. Now, if you have distinct values, they end up being more or less the same, but you can have duplicates and things. And a lot of them don't actually care. Things like row number, or the list down here, row number, rank, dense rank, percent rank, cumulative distance, and entile, don't actually care whether you are in a rows or range window. So what it will basically, it's used to now, it can be used for other things, but the thing that's in there now, that if this runs on a range window, it'll actually just rewrite it to a rows window because it's faster. And the slow one is the default, which is why this optimization will actually hit you and work in the default case. So basically, of course, depending on how your data looks, but in a lot of cases, these window functions will simply be faster. Those are the things that I've singled out so far, but again, we are very early in the last commit fest. So hopefully, this will not be the final feature set. Like, it could be that we won't manage to finish a single thing that's still in the queue. I really hope that's not the case, and I don't think it is. I think there is a lot of other things that are going to go in. So I've created a little sort of random dump of other things that you might find interesting. And one thing to consider about that is if there is something on that list that you really would like, you go like, that would be great for me and my systems, then please go in. You can get this patch from the Postgres CommitFest app. You can download, you can apply it, you can test it for us and let us know if it worked. That will, for some cases, drastically increase the chances that it'll get in. Or even just letting us know that this is a feature that would be really useful to you, because that'll help us prioritize between the remaining features. So, make your list, see where it goes. So I'm going to start with a simple management feature that we actually don't have, and it's kind of similar. We have a lot of different timeouts in Postgres. We have a patch in the queue for transaction timeout. So right now we have timeouts for statements, and we have timeouts for idle transactions, and we have timeouts for idle sessions. This is a timeout for total transaction time. So if you just run a single statement, that would be the same, right? But if you're running multiple statements in a transaction, and if you consider it for a lot of like web systems or whatever, what is the rule? Like if you take longer than 30 seconds to render the web page, the customer is gone anyway, something like that. So and also at 2 minutes, your web server is also gone, but Postgres keeps running it. So in this case, you could just set a transaction timeout, and it doesn't matter whether you're running 100 commands and hit the timeout or 1 and hit the timeout. So personally, I think this is one of those. It's pretty simple, but when you think about it, it actually has a lot of uses to stop wasting performance if nobody's going to read the reply anyway. You might not want to set it globally, because a lot of things will stop working if you just kill everything after 30 seconds. But for specific systems, it can be really useful. So I mentioned there are further additions to this pgstat.io view coming up. There's I/O timing coming up. There's related information about shared buffers. Obviously, buffers and I/O go very close together. those are sort of split out of that one, so I think they're very likely to go in as they're close in. There is some more checkpointer-related statistics. There is a view that I think the current name for it is pgstat_session, which will, the idea is you now have pgstat activity, which shows what's going on right now. pgstat_session would be some of the things that are in pgstat activity and also new things that are related to the entire lifetime of the session. Such as an example is, over the lifetime of this session, how much has it been active versus idle? Like that type of information. These are, I think, relatively likely to go in. We have a couple of things around the configuration of connections, SSL or TLS, whatever you want to call it. There's a patch in to allow you to use the system CA pool. So right now you have to put your root certificates in the Postgres directory and all those things. Configure it to use the system CA pool, depending on which pool you're on. Allow libpq to reject unexpected authentication requests. It's actually a pretty good feature, it just sounds weird, but right now, libpq will, like the server decides entirely on its own how authentication happens. So the server will go, hey, give me a password. And then libpq, if it has it, it'll happily send it. This will allow you to say, like, no, I don't do password authentication. I will only do Kerberos auth, whatever the server says. Which means that if somebody manages to break into a man in the middle or something like that, it'll no longer get anywhere. There is a patch in for load balancing connections in libpq. Anyone who's used JDBC or the .NET drivers, they've had this for years. Basically allows you to say connect to this server or this server or this server or this server. And it'll rotate amongst them and connect to one that is there. At the SQL level, there are some improvements to merge. There is a merge was new in Postgres 15, right? There is a patch that adds a merge returning. So returning clause just like we have for update returning and insert returning. For anyone who listened to my confusing reply to a question in the talk yesterday about merge not supporting delete, I was referring in a bad way to this when not matched by source. So right now, when you do merge, you can do deletes, but you cannot. Like when the merge runs, you have a source and a target, and you can only act upon things that actually exist in the source. You can say, based on what exists in the source, you can delete in the target. When not matched by source, lets you act on things that don't exist in the source and say, if it don't exist, delete it, things like that. But basic deletes when it joins. I'm not sure, you'll have to tell me if that's a good example, but I'm saying like a regular merge with delete on this is kind of like a left join. And with this, you can now do a full outer join in this sort of virtual join that is merge. There is work going on to get actual SQL JSON. This is the patch that was included in 15 up until right before the release, and then it was removed because there were some fundamental issues found with it. This is it's two parts, right? One of them is having sort of SQL standard syntax to access the existing JSON functionality of Postgres. There isn't, I think there's like one tiny thing of actual new functionality, but just being able to do it the standard way is pretty good, right? And then there is the big function, which is JSON table, which is similar to XML table, but for JSON. So you can take a large JSON document or a set of JSON documents and say, here are my rules to transform this JSON document into a table. And use that, for example, for data loading or things like that. So parts of it has already gone in. The parts that have gone in are basically the infrastructure parts that you will not see. There is at least a reasonable chance that we will see the full thing, I think. But hard to tell. At this point, I'd say if someone finds another major issue in it, it's not going to go in. If they don't, then it's probably going to go in. So yeah, cautious optimism is a good word, but we'll see. It's always tricky once. What was it you said yesterday, Bruce? With merge has been going for 12 years since the first submission, and it went in and out at least once or maybe even twice. So we'll see, but we'll hope. We should always hope. On the performance side, just one of those, it's one of those you look at and goes like, oh, there's just this one entry, just this parallel full hash join or parallel hash full join. Yeah, if you're doing full joins, they're slow. And doing them in a hashed way and being able to access more parallel query It's obviously going to make those things faster. That's exactly the type of query plan that can really benefit from parallelism if we can get there. And that's my selection of things from the queue. There are a bunch of other things in the queue. There are obviously other things already committed. We'll see exactly where that goes. There's a lot of stuff in there that isn't really user visible. Things will just run faster. And in a way, right, except when you're trying to make a presentation like this, those are the best kind of performance improvement, right? We just upgrade and everything's faster. So it's in there, and again, if there are contributors in the room and I didn't mention your feature, I'm sorry, you have to bribe me better next time, and I'll put yours in there. But to the rest of you in here as well, there are snapshot versions available in all packagings, well, in the major packaging systems, so there are RPMs, there are APT packages available for Postgres now. Now, don't go upgrade your production yet. I really recommend, you can, but I wouldn't recommend it. But you don't actually have to wait for beta versions. So if you're interested in any of those features that I mentioned that are already in, install this and test them. Finding bugs in them now will be much easier to get them fixed. Then we have a chance to fix them, right? If we find those bugs at the very end of the beta testing period, the only choice we have might be to revert the whole feature in order to get the release out. So finding these things early, download it and help. Run your workloads on it and let us know what we broke. I'm sure we broke something, otherwise we didn't really try. But do those things. It really does help us a lot. Again, if you are a C developer or skilled on C, then please participate in the commit fest. Help review some patches. If you're not, well, if you know enough to compile a program, /configure and make install, try out. You can still help as a reviewer. You can download the patch and you can just say, hey, it works. Or, I tried it and it didn't work. Like, at that level, this is still very, very useful information for our developers at this point. Yes? Oh yeah, that's a good point as Jonathan makes. You don't even need to use autoconf and those things these days. One of the features that you don't really have to care about as a user is that you can now build Postgres using Meson and Ninja instead of autoconf and makefiles. It can make things easier to get rolling. It builds things faster. Things like that. But so yeah, and please try that one out as well. But in general, like, the sooner that we can get our code exposed to your workloads, the better, right? It increases the chances that once we are ready to ship Postgres 16, it really is ready and it has the stuff that you actually need and want. That's all I had for this time. Any questions? Total silence. Yes, we have a question over there. So the question is, are there any special care needed for upgrading across the change to ICU? Because some of us have felt the pain of some libc upgrades where they did it incompatible. So based on this change, no, because the change is the default provider, right? If you are upgrading a system using PG Upgrade, for example, the provider is in the database, so it will not change. It will still use the libc provider, which means you will still have the problems of upgrading Ubuntu, right? Or whatever. Now, if you are doing a dump and reload upgrade and doing a new initdb with a different provider, then potentially, if you're using English sorting order, it's probably not changing, and you won't get corruption, right? That's the problem with the upgrades of glibc, is like it causes corruption. But if dump and reload always get you past this corruption. But if you're sorting by and the default locale has changed, then again, I don't think it will affect English, but in some languages, the ICU might be marginally different than glibc. I think actually one of the main reasons for this breaking change they did in glibc was to align it with what Unicode defines as should be the default and what ICU was already doing. So keep an eye out on it, but it's not like that glibc upgrade where you were in for a serious amount of pain if you didn't notice it. Yeah, there are things like ICU in general provides us with the ability to do a lot more to work around the remaining pains of locales. There will be more done, and getting the default over there, getting more people to use ICU will make it simpler for the future on that side. Anyone else? Okay, then thank you very much for paying attention. Enjoy the rest of your day.